Welcome back to this video wherein we are answering some problems relating to simple harmonic motion. So let's get started. So here we have a 4 kilogram of mass that is placed on a spring's end and displaced 2 meters to the right. So that means that the amplitude here is 2 meters. The spring force F versus its displacement from equilibrium is shown in the graph. So we have here the force and the displacement. How do you know that the mass is undergoing simple harmonic motion? Well, we notice here that if we have the displacement, which is 2 meters, the force is -10. If we notice here that if we notice that the displacement is 0, this is also 0. The force is 0. If the displacement is at the negative side, then the force is 10 newtons. We know that in SHM, or simple harmonic motion, acceleration is directly proportional to the negative of displacement. Since F is equal to ma, then we say that in this graph, we can say that the force is directly proportional to the negative of displacement. So, thus, we can say that this is undergoing simple harmonic motion. All you need to do is just to relate the quantities here. How about for the next problem? Find the spring constant of the spring. And what is the formula here? We know that Hooke's law is equal to F is equal to -kx. Do we have an F? Do we have an x? Yes. We can just choose some quantities here. And here, we can choose 1, and this one is going to be -5. But actually, you can choose whatever point you would like to have. So force is -5, x is 1. So that means that k is negative times -5 all over 1 is 5 newtons per meter. Find the total energy of the system. We know that the formula for the energy is total energy is equal to potential energy plus kinetic energy. But we can also express this into potential. Total energy is also equal to potential energy, but make sure that kinetic energy is 0. Total energy is also equal to kinetic energy. And in this one, we can express this as total energy is equal to 1/2 kx squared, which is equal to potential energy. So where can we do this? Remember that the kinetic energy is 0 at the ends, at the amplitudes. So that means that we can use this formula. So 1/2 times 5, which is the spring's constant, times x, which is the amplitude. So we will be having 10 joules. Find the maximum speed of the mass. So we're looking for the maximum speed. So we can also have total energy is also equal to kinetic energy. And of course, we are going to use the equilibrium position because we know that there is no potential energy in the equilibrium position. So we have 10 is equal to 1/2 times 4, which is the mass, times v, the maximum speed. So that means that at the equilibrium position, it is moving at 2.2 meters per second. Let's have the last problem. Find the speed of the mass when its displacement is 1 meter. So here, what is the displacement here? So here we need to use the total energy, which is 1/2 mv squared plus 1/2 kx squared. We cannot just easily cancel potential energy and kinetic energy because there is a value for each. So we have 10, which is the total energy, 1/2 times 4 times v, which is the speed that we're getting, plus 1/2 times k, which is 5, times x, which is the displacement. Notice that this is not the amplitude, and this is just considered as the displacement from the equilibrium position. Then we have v, which is 1.9 meters per second. I hope that everything is clear. However, if ever that you have questions, feel free to send me a message or just to contact me in emails. I hope that you're having a great day, and keep learning and keep pushing. If ever that you finish this video, I would like to thank you for not skipping, not just not ending the video just after 1 minute of watching it. Thank you very much and have a great day.